Welcome to Center Math's series on unusual properties in math. Today we're going to talk a little bit about functions with unusual continuity properties. So first, we can give one example of a function that is not continuous anywhere, but if we take the absolute value of the function, it'll be continuous everywhere. So we'll take f of x equals 1 if x is rational, and minus 1 if x is irrational, x is any real number. Note the absolute value just gives the absolute value of this function just f of x equals 1 everywhere, so it's continuous everywhere. And also note, so the rationals and irrationals are both dense on the real number line. Note, if we have any open interval a, b, we can always find an irrational between these points a, b. Just take 1 over n smaller than b over b minus a, or 1 over n, absolute value 1 over n smaller than absolute value b minus a. And then you can just add or subtract integer values of 1 over n. Eventually you'll end up in the interval. And note, since any interval is open interval is homeomorphic or has the same cardinality as the entire real line, if there were not any irrational numbers in an interval, it would be all rational numbers, but the rational numbers are countable and the real line is uncountable, and that would be a contradiction. So there are irrationals also contained in any interval. And so since in any interval there are reals and there are irrationals and rationals, you take any point x, f of x equals 1 or minus 1, and no matter how small we make the interval around x, we always have the points don't get arbitrarily close. If it's irrational and it's 1, there are always irrational points 2 units away, and so it will not be continuous at that point. So we're going to give an example of a function continuous at only 1 point. So we're going to take f of x equals x if x is rational, minus x if x is irrational. So if we consider f of 0. 0 is rational, so it's just 0. So note both minus x and x, both these two functions approach to 0 as x approaches 0. So we can find if we take delta less than epsilon, then f of x equals x is minus x will be less than epsilon units away from 0. F of x equals x will do the same thing. So if we're on either of these branches, we're going to be approaching 0 regardless, and so it's in fact continuous at 0. So we can find delta around x such that if we're less than delta units away, we'll be less than epsilon units away from 0. F of x will be less than epsilon units away. And so this is not true if f of x does not equal 0, because in that case, f of x will equal x or minus x, which will also be some non-zero value. And since we know the rationals and irrationals are dense in any open interval, in any open interval around any of these non-zero points, we'll have points who, when we take f of x, will be on the other branch, and the other branch will be some greater than 0 units away, and so no matter how close we get, we're always going to be some distance away, and so it will not be continuous at any of these points. Thanks for watching. Please check out centermath.org, check out our blog, and follow us on Facebook and Twitter. If you like this video, please check out our other unusual properties in math videos. Thank you.